Hello and welcome. In this training, we will explore the mechanics of ingesting data into Snowflake, focusing specifically on the critical role of file formats. Let's get started. To begin, we need to understand the high-level mechanics of getting data into Snowflake. It is essentially a two-step process. First, your raw data files must be staged. This can be in a Snowflake-managed internal stage or an external cloud storage location like Amazon S3, Google Cloud Storage, or Azure Blob Storage. Once staged, we use the copy into command to load that data into a target table. While you can load data in bulk batches or continuously using Snowpipe, the crucial component in both methods is the file format. Think of the file format as the decoder ring. Without it, Snowflake sees only a stream of bytes and doesn't know where one record ends and the next begins. This diagram visualizes the ingestion flow. On the left, we start with raw data files. These move via an upload or put command into a stage location, which acts as a holding area. From the stage, data moves to the target table on the right. Crucially, notice the yellow node, the file format object. It inputs into the loading process, defining the structure so the data lands correctly in the table. Snowflake is versatile in the types of data it can ingest. We categorize these into structured and semi-structured formats. For structured data, we primarily deal with delimited text, such as CSV or TSV files. For semi-structured data, Snowflake natively supports JSON, Avro, ORC, Parquet, and XML. A powerful feature here is that Snowflake can ingest these semi-structured formats directly into a variant column without requiring you to define a schema upfront. Additionally, you generally don't need to decompress files before loading. Snowflake automatically detects and handles common compression methods like gzip and zstd. Here we see the landscape of supported formats. On the structured branch, we have standard text formats like CSV. The semi-structured branch includes rich formats like JSON and Parquet. Finally, the compression node reminds us that Snowflake handles the decompression for these formats automatically during the load. How do we tell Snowflake which format we are using? You have two options. You can define the format details inline directly within your copy into command, or preferably, you can create a named file format object using the create file format command. This named object encapsulates all your settings such as file type, delimiters, and compression into a single reusable entity. This is the recommended best practice because it ensures consistency across your data pipelines and simplifies your loading scripts. You simply reference the format name rather than retyping technical specifications every time. This diagram represents the relationship between the load command and the format. The copy command class represents the action of loading data. It references the file format class. The file format contains specific attributes like type e.g. CSV, compression settings, and delimiters. By decoupling these, we make the copy command cleaner and the file format reusable. When working with structured CSV data, precise configuration is key. You must specify the record delimiter to tell Snowflake where a row ends, and the field delimiter to separate columns. A very common requirement is using skip header, which allows you to ignore the first few rows containing column names. Also, if your data contains commas within the text, you will need the field optionally enclosed by option to handle quoted strings correctly. Finally, the error on column count mismatch option determines if the load should fail when the file structure doesn't perfectly match the target table. We trace a CSV file's journey through parsing options. The input CSV enters the decision diamond. If skip header is set, the first row is ignored. The field delimiter splits the raw text into columns. The enclosed by setting ensures commas inside quotes are treated as text, not delimiters. All these logic paths converge to produce a clean, staged data record ready for loading. For semi-structured data, the options focus on parsing hierarchy. For JSON, strip outer array is essential. It removes the surrounding brackets, so Snowflake treats the file as a list of separate records rather than one giant array. For Parquet files, we have options like binary as text, which defaults to true and interprets columns with no defined logical type as UTF-8 text. We can also enable the use vectorized scanner for significantly reduced latency when loading Parquet files. These formats are typically loaded into a variant column, preserving the hierarchy for later querying. This state diagram compares JSON and Parquet processing. The top path shows raw JSON passing through the strip outer array state, breaking it into individual records before landing in a variant column. The bottom path shows raw Parquet utilizing the vectorized scanner state for optimized processing, before also landing in the variant column. Finally, we bring it all together with the copy into command. This command references the target table, the source stage, and the file format we just defined. Crucially, you can transform data on the fly by writing a select statement directly within the copy command, allowing you to reorder columns or cast types during the load. You can also use the validation mode parameter to check for errors without actually loading data, and apply filters using pattern to load only specific files. This command is the engine of data ingestion in Snowflake. This sequence diagram details the execution flow. The user initiates the copy into command. Snowflake requests the specific files from the stage based on patterns. The stage streams the data back. Snowflake then applies the file format rules we defined, performs any requested transformations, and finally commits the data, returning a confirmation to the user.